So let's take a quick look at how we factor by grouping. This is very closely related to finding GCFs, and I think you'll see that it's pretty straightforward once we get into it. So the first thing to realize is that not every problem has terms that share a single value. For example, the problem xc plus xb plus yc plus yb. If you look at this, there's not a single term that's shared between every single value. But as we're looking at it, we can see that some of these do share certain things. For example, over here, we notice that both of these terms share a y. Over here, both of these terms share an x. We could also see that xc and yc share the value c. And if you also look, you'll notice that xb and yb also share the term b. So our goal is to figure out what can we move around to create something that we can factor out, something that has a GCF. So in this case, I'm going to look at xc and yc and xb and yb. If I just rearrange my problem, I get xc plus yc plus xb plus yb. I can now look at this first section of the problem as sort of its own entity, as well as the second problem as its own entity. In the first problem, I notice they both share the value c, so that's our greatest common factor of these first two terms, and we'll factor it out and get c times x plus y. On the back half, we notice they both share b, so we'll factor that out as our GCF and get b times x plus y. As soon as this happens, you'll notice something interesting. We have the same phrase, x plus y, in the parentheses on both parts of the problem. So here's where factor by grouping comes in. We've factored out these individual values, c and b, and left ourselves with a shared value of x plus y for both. So now we're going to rearrange one last time and say that c plus b times x plus y is our factored value. So let's take a look and see if this works. At the top we have our original problem, and here we have our shortened version, or our factored version. So let's go ahead and follow our distributive method, or distributive property, reminding ourselves of the FOIL acronym, or you could use the box method and work it out. So following the distributive method, we get c times x, which is cx. Then we get c times y, which is cy. We get b times x, bx, and b times y, which is by. If we look at the top, you'll notice that these are the same values, cx and xc, cy and cy, by and by, bx and bx. The only difference is the order I've written the actual letters in, which doesn't affect the problem. So we can see that we can pull out certain letters by changing how we group these problems. Let's look at a couple of numerical examples and see what happens. So here's our new example. And our first trick is to figure out how are we going to group it. So we need to look for things that different parts share. We can see right off the bat that there's a y here and a y here. And you might also notice that both 10 and 15 have common factors. In this case, 1, 10, 2, 5, 1, 15, 3, 5. And you'll notice they have a common factor of 5. So that's a good thing. If you look at 14 and 21, while 21 doesn't have an x, you'll notice that 14 and 21 both share a common factor of 7. In this case, 2 times 7 or 3 times 7. So I'm going to go ahead and just say that those are probably how we're going to group them. So I'm going to rewrite my problem grouping those together. 10xy plus 15y plus 14x plus 21. And now I'm going to look at what can I pull out, or what are the GCFs of each individual section of my problem. In the first problem, I've already said that 5 is my common numerical factor, so I'll factor out a 5, and since they both share the value y, I'll factor out a y as well. One thing to remember is that it's GCF times whatever's left, so 10xy divided by 5y will give me 2x, and then 15y divided by 5y will give me 3. Moving on to the second half of my problem, 14 and 21 we already said shares the factor of 7, so I'll factor out that 7. We don't have an x to factor out, so I'll leave it as that. 14x divided by 7 gives me 2x, and 21 divided by 7 gives me positive 3. So immediately we can see that we factored out the same value on each side, which tells us that we're doing things correctly. So finally, we'll rewrite it as two single factors by taking our coefficients, 5y and 7, putting them into one set of parentheses, and putting what was left, our 2x plus 3, into the other. Once again, because this is factoring, we can check really quick to see if we've done things correctly. So we multiply across, we get 10xy. We multiply our outer values, we'll get 15y. We multiply our inner values, we get 14x. And we multiply our last values, and we get 21. Since this matches our original equation, we're correct, and we've done things properly. Let's look at one more example. In this case, we have 10xz minus 65x plus 8yz minus 52y. In this case, the hardest part is figuring out what is it that we need to group together. And so one of the easiest ways to do that is simply to go ahead and start writing down factors of each of these numbers. So let's start with 10 and break 10 down into its factors. 10 breaks down into 1 times 10 and 2 times 5. So let's look at 65. 65 breaks down into 1 times 65 and 5 times 13. And real quick, we'll do 8 and 52 as well. So we see that 8 breaks down into 1 times 8 and 2 times 4, and 52 breaks down into 1, 52, 2 times 26, or 4 times 13. As we look at these, we hopefully can start to pick out certain values that are going to work well together. While you're looking, you may notice that, for example, 10 and 52 both share the value of 2. But instead of just jumping on the bandwagon right there, I'm also going to look at the variables. 10 has an x and a z, whereas 52 just has a y. Since none of those variables match, I'm going to keep looking and see if there's a value where everything matches, both numbers and variables. So once again, looking at 10, I can see that it has 5 as a factor, as does 65, and I also notice that they both share x as a common factor. If I look at 8 and 52, I notice that they both share 4, as well as the value for y. So I'm going to go ahead and break up my problem just as it's written into 10xz minus 65x and 8yz minus 52y. And I'll factor out of each of those. So one thing you can always use to remember what you're doing is that you're factoring out GCFs, and you'll end up with the GCF times what's left. Okay, that's a great way to remember what should be in the parentheses and what should be outside. So my GCF for this first section will be 5x, and if I divide 10xz by 5x, I'll get 2z. If I divide negative 65x by 5x, I'll get negative 13. So that will be my first section. For my second section, I know that my GCF will be 4y, because they share both a 4 and a y, and I'll divide. 8yz divided by 4y will give me 2z, and negative 52y divided by 4y will give me negative 13. Immediately you can see that our term here and our term here match, which means we've done things correctly. So once again, I'll finish my factor by grouping by pulling out my two coefficients, 5x minus 4y, and multiply them by the remaining factor, 2z minus 13. Once again, if we work this out and do our multiplication, following our distributive method, we'll end up back at our original problem, 10xz minus 65x plus 8yz minus 52y. Remember, whenever we're doing factoring, it's one of those math problems that you can always check. You can always make sure you're correct simply by working the math out. And in this case, our math works out. So here are the three keys to remember. You need to group everything based on the GCF. So if you end up with a problem like this, ax plus bx plus ay plus by, think about what you can pull out from each term and what is shared. So you might group it according to this, giving yourselves the x's on one side and the y's on the other. Okay? After that, you need to get to the GCF times what's left. In this case, you'd have x times a plus b plus y times a plus b. Always remember that these two terms have to match in order to do GCF factoring by grouping. And in the end, you want to make sure that you've simplified to two binomials. So you get x plus y, your first two coefficients, times what was left, a plus b.